Hello students, in this video we'll classify minimal surfaces of revolution. Let's consider a surface of revolution R of u and v, which is f of u cosine v, f of u sine v, and then g of u like so. In arclength parameter, so that f dot squared plus g dot squared is equal to 1. We know the first fundamental form. The first fundamental form is du squared plus f squared dv squared. And the second fundamental form, 2, is going to be what? Is going to be f dot g double dot minus g dot f double dot du squared plus f g dot dv squared. Okay? And so I'd like to figure out now what are the minimal surfaces of revolution, right? So I would like to set h, which is going to be what? H is going to be L times what? L times g minus 2mf plus n times e over e g minus f squared. There are no f terms in either of those expressions, so those are gone, right? So middle terms are gone. And then LG is just what? It's just going to be this times f squared, right? The bottom is going to be f squared. So there's an f squared over here. That's going to cancel with the f on top over there, right? So h equals 0 equals h is equal to what? Is equal to, and there's probably 2 in the denominator too, but we don't care about that so much because we're going to set the denominator equal to 0, right? So I need a 2 over here as well, right? Okay. And then what? And then this is going to be a f double dot, an f dot, single dot, f single dot, f single dot, g double dot, and then minus g dot, f double dot, and then plus what? Plus n times e, so that's going to be a g dot over f, and I want this to be equal to 0, right? So I need to solve this differential equation. Now, of course, I can make some simplifications of this because I know that from this expression over here that f dot f double dot plus g dot g double dot is equal to 0 by differentiating this equation. And so what that tells me is the following. That tells me that if I look at this expression, f dot g double dot minus f double dot g dot, and I hit that expression with a g dot, what this becomes is it becomes f dot and then g double dot dot g is the same as negative f dot f double dot. And then this is going to be what? This is going to be minus f double dot and then 1 minus f dot squared, right? So this whole thing is just going to simplify to negative f double dot, okay? So our minimal surface equation now takes the following form. Takes the form 0 is equal to this expression is equal to what? Is equal to negative f double dot over g dot plus g dot over f, all right? Which tells me that f double dot f is equal to what? F double is equal to g dot squared, which is 1 minus f dot squared. And so that is our minimal surface equation for a surface of revolution. Now what I'm going to do is the following. I'm going to let h be f dot. Then h dot is f double dot. And that's also equal to what? H dot is also equal to dh df times f dot, df dt. That's dh df times h itself, okay? So if I make this substitution, my differential equation becomes the following. It becomes dh df times f. That's my f double dot. And it's going to be an f, so my f double dot is what? Times f times h, of course, is equal to 1 minus h squared, which is now a separable differential equation, right? So now I can write this in the following way. This is h over 1 minus h squared dh is equal to df over f. So if I integrate this, I'm going to get what? I'm going to get the negative 1/2, the logarithm of 1 minus h squared is equal to the log of a constant c times f, like so. Great. And so now, of course, this tells me that c times f is equal to 1 over the square root of 1 minus h squared, like that. Good? And so I square both sides and get c squared f squared is equal to 1 over 1 minus h squared. Take a reciprocal both sides and get that 1 minus h squared is equal to 1 over c squared f squared. And therefore, h squared is equal to what? H squared is equal to a 1 minus 1 over c squared f squared, like that, which is c squared f squared minus 1 over c squared f squared. So h is going to be what? So h, therefore, is going to be equal to what? H is going to be equal to the square root of this thing. So I'm going to have the square root of c squared f squared minus 1 over c squared f squared, which is just going to be the square root of c squared f squared minus 1 over cf. Great. Okay? That's df dt, right? So I'm going to multiply the reciprocal. And if I do that, so of course this is df dt, this is really f dot. So I can put all the f's on the other side. So that says that df times cf over the square root of c squared f squared minus 1 is equal to what? Is equal to just a dt, right? So now I can integrate this thing over here, right? So this is going to be really be what? So in other words, the derivative of this thing is 2c squared, so I got an extra 1 over c, right? So I can put an extra 1 over c, put c squared over here, and then the 1 over c over here to make my life easier, right? Because now that's the derivative of this thing over here, right? And then I also need a 2, I think, right? And then up to a factor of 2. So I differentiate, I get a 2c squared. So I'm going to put a 2 over here, a 2, and then a 2 in the denominator, right? Good, so now the derivative of this thing over here is exactly equal to this thing as a perfect derivative now, right? So now I get that 1 over 2c times the square root, and then the 2 is going to cancel out actually with the power. I'm going to have a square root of c squared f squared minus 1 is equal to t plus a constant c tilde, okay? And so by multiplying by t and squaring, I'm going to have what? I'm going to have c squared f squared minus 1 is equal to another constant, c t plus, I'll call that d, right? And then we're going to add 1 to that, and so that says that c squared f squared is equal to what? It's equal to 1 plus ct plus d. That's going to be a constant over there. And then divide by c. I get the square root. I can conclude the f of t is equal to 1 over c. 1 over c times the square root of a constant 1 plus ct. And that should be a square root there, right? Good? All right. With plus ct, and then make sure all my t's in the right spot over here. dt, perfect, 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 perfect. And that's a square everything over there. So now I take the square root of that thing over there. Good. And I have a t squared over here. T squared going. So my t squared going where? Where's my t squared going? Oh, I'm going to square this over here to get rid of the square root, right? So I'd have to square this over here. So when I square this, it's going to be this thing over here squared. Good. All right. And that's going to be a squared over here. And plus 1 squared. There's my squared. ct plus d y squared. Excellent. All right, good. And so that has to be a formula for f, right? And so now since g is an arclength parameter, we can show that this applies that g dot, it do what? By taking the derivative of this thing, we have in the denominator, so this is going to be what? And taking the square root, I have a 1 over square root of 1 plus a modified constant c t squared, which is going to allow me to conclude that g of t is going to be what? Be 1 over c1, 1 over c1, the inverse sinh, hyperbolic sinh of c1t. And if this is my formulation for g, then by taking the inverse sinh of this thing, we're able to conclude over here that f of t has to be a multiple c1 tilde, the cosh of, I call this over here, c2 tilde t. And that tells me the only parameterized surfaces, the only surfaces of revolution, minimal surfaces, that are minimal surfaces have to be what? Have to be canoids. So these are canoids. Are the only surfaces of revolution which are minimal surfaces. Thank you very much.